Hi everyone, I'm Mateja, and today I'd like to present to you Euler's formula. Now, some of you might have no idea what Euler's formula is, and that's okay, because in this short video, it's going to be my job to teach you. Now let's get to it. What exactly is Euler's formula? Well, it's a revolutionary formula that uses trigonometric and logarithmic identities to raise numbers to imaginary powers. To someone without much background in mathematics, that sounds impossible. But it does work, and that's what I'm going to be showing to you today. Pictured here is Euler's formula. E to the it equals cosine t plus I sine t, where t is any real number, and it is calculated in radians. In order to do any calculations, though, we need to know some logarithmic identities. In this video, we will be dealing with the top two. The other two are important to more complex calculations. Say you want to do some calculations with this. If you had e to the I pi, that's pretty easy. Pi is your t, plug it in, call her good. Now, if you had 7 to the I, you need to convert it with a base of e. If you recall a logarithmic identity, e to ln x equals x, we set x equal to 7i, and there we go. We have e to the ln 7 to the I, or e to the I ln 7, and it's in that form we need. We can plug it in. Cosine ln 7 plus I sine ln 7 equals negative 0.37 plus 0.93 I. To give you a visual representation of this, I graphed it on a complex coordinate system. So that little red dot right there is 7 to the I, or negative 0.37 plus 0.3 I. And notice how it's on the unit circle? That's a funny coincidence, isn't it? That unit circle coincidence isn't a coincidence at all. I have 2 to the I, 42 to the I, and 100 to the I here with 7 to the I. I calculated these values and graphed them. Look, 2 to the I on the unit circle, 42 to the I on the unit circle, 100 to the I on the unit circle. This can be explained with easy trig. The x value is the cosine, which is x over r, and then the y value is the sine value, so it's y over r, and that leaves it with a radius of 1. Thanks for listening, and I encourage you to keep looking into Euler's formula on your own, because it's pretty cool.